All right, hello everyone. My name is Michael, and I'm going to be looking at problem 7 from the target round of High School Test 12502, which is for November 2024. So let's take a look. Let P be the product of all but one of the positive divisors of 10 factorial. The sum of all possible values of 1 over P can be expressed as A over B for relatively prime positive integers A and B. Compute A. Now, at first glance, you might say, why is it not compute A plus B? Well, we'll take a look at why it's not compute A plus B. Now, let's say that the product of all of the positive divisors of 10 factorial is equal to x, right? Now, and let's say that there is a set of divisors d sub I that represents the divisors of 10 factorial. The positive divisors of 10 factorial are the set d sub I for I up to the number of divisors that 10 factorial has, and x we're going to have be the product of all positive divisors of 10 factorial. So we know, right, that the value of p, right, is just going to be x over d sub some number n. We're just the nth factor. Right, so therefore, right, 1 over p is just going to be some divisor, right, of 10 factorial. That 10 looks ugly, let's fix that. Some divisor of 10 factorial divided by x. So that means that the value of 1 over p is always a divisor of 10 factorial divided by the product of all positive divisors of 10 factorial. So the sum of all possible values of 1 over p is going to be the sum of all divisors of 10 factorial, right, divided by the product of all of the divisors of 10 factorial. Now, 10 factorial, right, is equal to 2 to the 8th times 3 to the 4th times 5 squared times 7. Yes. So that means that the sum of all of the positive divisors of 10 factorial is going to be equal to 2 to the 0 plus 2 to the 1 plus 2 to the 2 all the way up to 2 to the 8th, right, times 3 to the 0 plus 3 to the 1 plus 3 squared plus 3 cubed plus 3 to the 4th times 5 to the 0 plus 5 to the 1st plus 5 to the 2nd times 7 to the 0 plus 7 to the 1st. And this comes out to be equal to 511 times 121 times 31 times 8. Right. And that's the numerator of our fraction. Now, the denominator is the product of all of the positive divisors of 10 factorial. Now, you might be wondering, what is that? Well, let's see. The number of divisors of 10 factorial is 9 times 5 times 3 times 2, which is 270. So that means that there are 135 factor pairs of 10 factorial. So that means that x right here is actually, right, equal to not 10 to the 135, but 10 factorial to the 135th power. And that's why we are not calculating the denominator, we're just looking at the numerator. Now, because remember, 10 factorial is already 3,628,800. So raising that to the 135th power is not something that can be computed, even with a normal calculator. Now, we know that this 511 times 121 times 31 times 8 is the numerator, but we still have to simplify it, right? Because they need to be relatively prime positive integers. Now, we know that 10 only has 2, 3, 5, and 7 as prime factors. And we can see that 121 and 31 both only have prime factors greater than 10, so we don't have to worry about that. But the 8, right, can be canceled out, and 511 is equal to 7 times 73, so the 7 can also be canceled out. So that means that the value of A is actually equal to 73 times 121 times 31, and that comes out to 273,823, and that is going to be our value of A and our answer for this problem.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.